All right, so we are going to look at the at some examples. So for it says here, for each identify amplitude periods, phase shift and vertical shift, and B graph and identify key points on one full period. Holy cow! All right, so let's take a look at what's going on with y equals 2 sine of 2x. So it's being vertically stretched by a factor of 2, right? So it's a sine wave but made taller, and it's sine of 2x though. So remember that in the argument that multiplier 2 actually works counterintuitively, and it's a horizontal effect. So it's not a multiply by 2, it's divided by 2. So it's going to shrink from my period from 2 pi to pi, right? So I'll have a hilltop and a valley, a hill and a valley in a period of pi. Okay, there is no shift. All right, so my amplitude is 2. And again, the amplitude, remember, is the absolute value of whatever A is. The period is pi, right? Because it's 2 pi divided by B, which is 2 in this case. All right, my phase shift is nothing or 0. There is no phase shift. I'm going to say 0. And vertical shift, none. Okay, so no vertical shift. Okay. All right, so let's graph this. So 2 sine 2x. So instead of going from 0 to 2 pi, I'm going to go from 0 to pi. It's the sine wave. So the way I'm going to do it is, if you remember, we talked about hilltops and valleys. So from 0 to pi, half of that is going to be taken by a hilltop, and it's a sine wave. Remember, the sine wave starts at 0, 0, and then gets a hilltop, and then gets so first it gets a hill, right, from 0 to pi usually, and then a valley from pi to 2 pi. So because this is shrunk in half, instead of from 0 to pi it's a hill, it's from 0 to pi over 2, but it doesn't just go up to 1, it goes up to 2. So at pi over 4 will be the top of the hill, and then between pi over 2 and pi, the 3 pi over 4 will be the bottom of the hill. Okay, so let me fill in, right? I'm just going to draw my hill and my valley. So my hill goes up, touches there, comes back down to pi over 2, 0, down to 3 pi over 4, negative 1, and then up to pi 0. Notice it's just a sine wave, but shrunk in half horizontally and doubled vertically. Okay, so my key points then are 0, 0, pi over 4, 2, pi over 2, 0, 3 pi over 4, comma, negative 2, and pi 0. Pi 0. Okay? All right, good deal. Let's try number 3, and we'll leave number 2 and number 4 for class. Number 3, y equals negative half cosine 2x minus pi plus half. Okay, so I have a negative half is my A. That means it's going to shrink vertically, right? So instead of going from negative 1 to 1, it'll go from negative half to half. Plus 3 halves, so not from negative half to half, but shifted up 3 halves. Okay, so we'll take care of that in a second. But horizontally, I have a 2 in there. Now, to know exactly how that 2 is working, I want to factor out the 2 from the quantity 2x minus pi. So I can think of this as 2 times x minus pi over 2. And what that does is it actually shows me the actual shift. My shift is actually pi over 2 to the right, and my period is because of that 2, it is again shrunk in half. This is the cosine, remember. Okay, so I'm going to do my shifting first, and then I'll apply the shrinks and such. Okay, so first, if I were to consider the cosine goes from 0 to 2 pi, or 3 pi over 2 to negative pi over 2 to 3 pi over 2. Okay? Now, this is going to shift pi over 2 to the right, so it'll go from 0 to 2 pi, and it's going to shift up by 3 halves. Yeah? So my x-axis is really at at y equals 3/2, right? My x-axis got shifted up that way. Okay, so because I know that my hills go from the x-axis up and my valleys go from my x-axis down, I'm going to look now at this shift, and I call that my shifted x-axis. So my hill goes from there up, from the line y equals 3/2 up, and the line y equals 3/2 down will be my valleys. All right, and because I have shifted by pi over 2, my cosine really looks like my sine wave. Do you guys remember we talked about that? That the sine is the cosine shifted by pi over 2. This is the cosine shifted by pi over 2 to the right. So it's like the sine wave. So it starts at on the y-axis at where my x-axis is, my shifted x-axis. Okay, except that it's not going to go from 0 to 2 pi. It's going to go from 0 to pi. So I'm going to mark off the halfway point and the quarter point and the 3/4 point. Okay? All right. And that negative half in the front, the A, is going to make that, instead of going up 1 and down 1 as the amplitude, it only goes up half and down half, except it's upside down. So if I think of my sine wave upside down, instead of the hill being first, it'll be the valley first. And it'll only go down half a unit. Yeah, so it's a shorter hill, both vertically and horizontally. Okay, and it's upside down. So my valley now is going to be my hill. There's my graph. So it starts from 0 3/2, then it takes a valley from 0 3/2 down to pi over 4 1, back up to pi over 2 3/2. Okay, and then from pi over 2 to pi, there's a hill. So it starts at pi over 2 3/2, goes up to 3 pi over 4 2. And then goes back down to pi 3/2. Okay, all right. So I'm going to mark off my those key points. So the first one is 0 3/2. The second one is pi over 4 1. Notice we just talked about these. Pi over 2 3/2. That's halfway through my shifted cosine wave. 3 pi over 4 comma 2, 3 pi over 4 comma 2, and then pi comma 3/2, pi comma 3/2, and of course we could call 3/2 1.5. All right, now let's mention what each of these are. So we were supposed to indicate what the amplitude, so the amplitude is absolute value of negative half. So the amplitude is the absolute value of negative half, which is 1/2. All right, the period, we just need to give the length. We don't need to give from where to where, is pi. The phase shift is pi over 2. Remember, if we look at the way the equation is given, it's b times x minus c over b. That's one of the equations that we read, and the shift is the c over b, so it's pi over 2, which, because it's positive, means it's pi over 2 to the because it's x minus pi over 2. Yeah, pi over 2 to the right. And vertical shift. So vertical shift, 3/2. There it is. All right, let's do one more. Let's do number 1 on the next page, which says write a function of the form y equals a cosine of the quantity bx minus c plus d, or y equals a sine. It says cosine, but it should be sine. A sine of the quantity bx minus c plus d for the graph. All right, so I'm looking at a graph, and it starts at 0 0. And then it has a valley at pi over 2 negative 1, and then it's at pi 0, then 3 pi over 2 2, negative 2, I'm sorry, pi over 2, negative 2, then at pi 0, then 3 pi over 2, 2, then at 2 pi 0. All right, so the period's 2 pi, so b is 1. And it's like the sine wave, but it's upside down, so a will be negative 2. And I think that's it. So we can write y equals negative 2 sine of x. Yeah. And in class we'll talk about, could we write a cosine function for it? Okay. And I'll leave the others examples for class. So I'm gonna leave it there. And we'll talk about in class what we're gonna do for the 2 days of class this week. All right. Thank you all.